two port network parameters. That will be covered, but you people have to write down something in your notebook. Yeah. Yes, gentlemen, can you sit here on the front bench? He is very sincere, by the way. He gives correct answer, but yeah, I'm praising you. It does not mean that you should not come here. First, yeah. If the guy who is attentive at the back means it's good. If he will be at the front, he will be more attentive, right? Anyway, so we talked about various parameters, and we also learn, or we try to solve some of the questions. But we learn one thing. We are very poor at KCL, KVL. So please try to solve those mesh analysis and nodal analysis, so that you are expert of that. That will be very useful, right? But other than that, so this was the first thing which we have learned. The real thing we have not learned, or I was not giving answers completely yesterday, because there are lots of things through which you can solve y and z parameter or all the parameters. Look, writing matrices are not difficult, right? So the second method says that it's by inspection. So that's the second method. But this method or the first method are not applicable to all the networks. Sometimes you have to apply the third method. If time permits today, depending on your speed, I'll go to third method. Otherwise, let's learn by inspection. So there is one more thing. Let's revisit y and z parameter. Do we know other name of y and z parameter? This parameter, basically known as, one of the parameter is known as open circuit parameter, one of the parameter is known as short circuit parameter. Can you tell me which one is open and which one is short? And Divyanshu? Yeah. So which parameter is known as open circuit parameter and which one is short circuit parameter? Yeah, Gaurav. Okay, so Gaurav is saying open and this one will go to surely short, right? If this is open. But how did you get this answer? Okay, so you are saying that in Z parameter, V1 and V2 are dependent parameter, and you are writing Z11 times I1 plus Z12 times I2, and this is Z121 times I1, and this is Z22 times I2. Similarly, you are writing here I1 is equal to Y11 times V1 plus Y12 times V2. I2 is equal to Y21 times V1 plus Y22 times V2, where Z11 is equal to V1 divided by I1, where I2 is equal to 0, and similarly Z12 is equal to V1 divided by I2 when I1 equal to 0. Similarly, you can write down Z21 and Z22. This is when I2 equal to 0, and this is when I1 equal to 0. When you want to find out Y11, Y12 and Y21, Y22, these two parameters when, so these two parameters when V2 equal to 0 and these two parameters when V1 equal to 0, right? Whenever you want to keep some voltage sources which are independent by nature, if you are short, if they are 0, means you need to connect these two terminals tied with each other, means you are doing the short circuit, and that's how the name of this parameter is short circuit. And for this case, you are removing currents which are open circuiting the current sources, so you are calling such parameter as open circuited parameter, right? So we are going to find out y parameters or z parameters using something called observations or the inspection. When you are doing the inspections, we have to understand following things, that y parameter is nothing but short circuited parameter and z is open circuited parameter. When we have to do it, we have to follow what two ports have been defined with. So what two ports are defined with if they are z parameters? So z11 is defined with v1 by i1 when i2 equal to 0. So wherever you are seeing I2, you need to make it open circuited, and other parameters you need to find out. Let's take some example. So are you following this till now? So those who are like newcomers and all the latecomers, so they are, for them, y parameter. Yes, Nikita, y parameter is short circuited parameter and z parameter is open circuited parameter, because in y parameter we are keeping voltage sources as 0. Voltage sources as 0. If you want to make voltage sources to 0, it has to be short circuited. If you want to keep current sources as 0, you need to make them open circuited, right? Okay. So this is one example. Now, if you want to use KCL, KVL, it's up to you, right? That's the first method. I cannot help you in that if you are not able to write down KCL. So please practice it. This is also first method where you can apply V1, I1 and V2, I2 on the basis of KCL and KVL. Okay, that is first method. You can do that by writing equations. No problem. But the other technique, which is called by inspections, what we want to do, we want to find out Z11, which is V1 by I1, Z12, which is V1 by I2, Z21 is equal to V2 by I1, and Z22 is equal to V2 by I2. But the most important thing is we are keeping I2 equal to 0 here, I1 equal to 0 here, this case I2 equal to 0, and this case I1 equal to 0. So this is the most important condition we need to take care. And when we are doing the inspection, we have to make sure that I2 equal to 0 if you are interested in finding out, let's say, Z11. So for this condition and for this condition, I am going to make a circuit where I2 equal to 0. If I want to make I2 equal to 0, so here there is some current is coming, but we are going to keep that current as 0 or the open circuited. Look, still there is some voltage V2 there, but whichever current is coming because of V2, it's 0 right now. This is by inspection. So let's draw the circuit. I am drawing the circuit where there are following things, because I am interested in finding out Z11 and Z21 when I2 equal to 0. For both the cases, this circuit is applicable where I2 is 0. Now, what I can write down, somebody can help me to write down V1 in terms of I1. Or sorry, you can write down I1 in terms of V1. So what value of I1 will be there? So whoever thinks he is very poor in this KCL, please raise your hand. I'll ask him. Nobody will raise. So who is the strongest in KCL, KVL? Mahima, what do you think? Mahima, are you strong, right? So tell me. So what will be I1? It's following the Ohm's law, and you have to follow plus and minus terminal. So the current should come back, right? So between plus and minus, what are you seeing? V1 divided by, look, right? This is the voltage here, right? Divided by 4 plus 8 in parallel of 8. Right? Now, no problem, right? There is no current I2, so this will not alter the things, right? So, can you tell me the equations? You have to solve this in your notebook. Please solve that. Otherwise, my observation for you people is you are not solving the things in your notebook. That's why you are creating problem. 16 by 5.
We can also write V1 by 4 plus V1 minus V2.
There are many ways to write down here. So this is not only one way. You can go other way around and you can write down V1 in terms of I1 also. Right? It's same. You have to follow the Ohm's law at room temperature. Okay. Yeah. So what is the final equation? V1 by I1 is equal to 5. 16 by 5. The unit of this one will be ohm, right? Even if it's you are converting everything in Laplace operator, still the unit of impedance will be ohm because this is V1 by I1, right? So this is going to give me Z11 directly. Can you see? When I2 equal to 0, by inspection I found out that Z11 is equal to 16 by 5 ohms, right? Similarly, now I'm interested in finding out, when I2 equal to 0, I'm interested in finding out Z21, which is equal to V2 by I1. Now, in this network, I don't find direct relation between V2 and I1, right? So there are many ways to find out V2 by I1. So I follow generally in terms of voltage ratio between V2 and V1. If I can find out that the relation between V2 and V1 and replacing V2 in terms of V1 here, I can find out Z21. You following the Gaurav? Right? So let's write down V2 in terms of V1. I'll tell you one question. This was the question asked to one of my friend when I was in my MTech. So for his interview, that interviewer has asked him this question, and I don't know, he gave the wrong answer. So if this is R1 and this is R2 and this is V out, this is V in, what will be V out in terms of V in? Yes, yeah. With spec. Who is designing PCB for design practical? Yeah. Huh? V out is equal to V in into R2 by R1 plus R2. So it's a voltage divider, right? Now, if I'm adding something here, what do you think? What's your name? Sorry, I forgot it. Mayank. So Mayank. Hmm? Huh? Divya? Piyush? Look, you have to follow uh, one thing. This is independent voltage source. If this is V in, any impedance you are connecting here for independent voltage source, it cannot change. It will change if you are adding some resistance, here, or maybe if there is a resistance here, then it will change. But if nothing is there, there is no voltage drop, so it will be V in only. Across this point and this point, you can apply anything, it has to be V in. So this was one of the questions that in interview they asked and he gave all the wrong answers maybe at that time. So it's same. And same thing is happening here. So can you write down V2 in terms of V1 now? So V2 is half of V1, right? Because both the resistances are equal, so half of V1. I can keep this half of V1 here, so it will be half of Z11, that is going to be give me Z21, and that will be 8 by 5. in ohms. So please make sure that I'm fond of all these units. One should not miss any unit. If it has been asked, find out Z11, Z12. So you have to write down the unit also. Without unit, it's useless, right? So please write down this, right? Any problem in finding out this? So now I want to find out whether I'm getting same answer or not. Yeah. So 8 by 5 and 16 by 5, right? So now the next question is, I am interested in finding out Z Z12 and Z21. Okay. I'm interested when I made a reverse thing. Okay. When I1 equal to 0, and if there is a circuit which has following things: R1, okay, 848, 8, 4. By the way, just to understand whether you remember or not, do you know the name of this circuit? There is some special name of this circuit. So it's called pi circuit. Okay, and the other one is like this. So generally, for all the competitive exams, people mucked up all these equations for pi and t. Answer will be same, right? So you can follow if you want to follow same thing. But otherwise, if you forget what are the equations, then you can solve the equations by inspection. Because by inspection also you can get it. So I don't remember any equation, frankly speaking. Okay, so I'm not giving any competitive exam. So, but if you are giving, then you can muck up this pi and t. Sometimes pi in parallel to pi will give you pi. So you have to find out pi in parallel of pi, t in parallel of t. And by the way, if you look at this t and pi, the different name of, do you know another name of t and pi, by the way? Have you studied this earlier before this course? Hmm? These are also known as delta network and Y. Okay, star. Okay. So some people call it Y also, right? Okay, because it looks like Y. That's why some people call it Y, right? So in power electronics, people call it delta and star. So we are going to call it pi and T. All circuit theory guys or who are leading to study analog circuit designing, they are going to call it pi and T, right? So now, if you are interested in, if here you have V1, here V2, earlier I made I2 equal to 0, but now I am going to keep I1 equal to 0. So when it is I1 equal to 0, so what I am going to see? Can you tell me? In the case of Z22, okay, so Z22, I'm not, if you want to solve me the questions, I can solve that also, but I'm not solving it. Okay, fine, Divyanshu. Okay, so can you tell me, Divyanshu, 24 by 5 ohms. What about Z21? Hmm? 8 by 5. Okay. So I believe Komal and Divya, right? All are getting same answer. Okay, so there is no problem in that case, right? Now, same theory, same thing, but you people have to solve this. Look, you people have to solve this kind of network where there is something called. So, what is the name of this voltage source? Is it dependent or independent? It's a dependent voltage source. It's not a function generator or the power supply through which you are getting this. So now you need to write down Z11 and Z12, which are equal to V1 by I1, V1 by I2 in both the cases when I1 equal to 0. Oh, sorry, I2 equal to, I made a mistake here. It has to be Z21 This is V2 by I1 when I2 equal to 0. So you have to solve that. If you need some help, look, you have to follow just KCL, KVL, Ohm's law, right? So let's use this circuit where I2 equal to 0. By the way, this circuit is known as T. Okay. Yes, Divya, you got something? Okay. So today Desraj is absent. Huh? So how much V1 you are seeing in terms of I1 or maybe other way around? Hmm? So I want to know what Z11 you are finding out. Hmm? Alpha plus R1. Okay. Is it correct? Everybody are getting same? Okay. What about Z21? Are you following Rohit or hmm? Dinesh? Can you sit here and look at his equations? Himanshu, can you help others, please? So, is there anybody else who wants my help? So my TA can sit with you and look at your equations. Raman, can you help? Maybe some girls. Nikita, are you following? Are you getting same answer? Okay. So those who are not getting the answer, please raise your hand so that my TA can help you. Can you check with those girls like Swarna, Vaishali, Khyati? So Khyati, you got the answer? Okay, fine, right? Because this is the last chance. Look, thereafter I'll not look back to these equations. I thought I should not start new topic because we have exam on 9, so we are practicing just some problems. If you need my help, if you want me to come there, I can also come there. There is no problem. Okay. Yeah, solve Dinesh. Everyone got the answer. Okay. Okay. So I solve this, right? So this is a solution. Like there are many ways to solve this, right? KCL, KVL, whatever way. I can write down this one also equal to no, so I can write down V1 equal to R1 plus I1 plus alpha I1 also, right? So there are many ways to solve this. Right? If you solved it, can you solve the next thing? When I1 equal to 0, you have to find out Z2 2 and Z1 2. Yeah, this is V2 by I2 and this is V1 by I2 when I1 equal to 0. By the way, this technique is known as by inspection. Okay. What we are doing is by inspection, by shorting or open circuiting particular network. So such networks you got in TI, right? Okay, so previously when Himanshu gave exam for TI last year for internship, he got some of the networks like this, which you need to solve by inspection, and you have to find out Z and Y parameters. Most of the time, you will be asked Z and Y. That is the most important nowadays. In previous century, people were complicated. They were using H and ABCD parameter, but yeah, we are easygoing and we only follow Z and Y. So Z22 R2, okay. Hmm? If it is wrong, I'm writing what he is saying. Okay, I haven't solved it. Okay, I follow what exactly he is saying. Okay, so V2 by I2 is R2. Yes. How did you get this? Yeah. Are you sure? Okay. If you are sure, no problem. Okay. Those who didn't get this answer, can you raise your hand? R2. 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 Right. Okay. What about Z12? 0. Okay. If somebody who is not getting this answer, just let me know. Right? I haven't solved it. I just keep faith on you. Okay. If somebody is getting different answer, please let me know. Okay. So these answers are correct, right? Okay. These answers are correct, right? And you can write down these with unit ohms. Okay. So this guy can do that, but we are not going to do this. Okay. We are not going to drop the unit. Anyway. So so there is. So are you following this till now? Is there any problem? Okay. If there is no problem, I'll ask you one, or we'll have a new technique. What I'm following is from same book, Franklin Covey. Okay, this everything is copied from there. Okay, so if the equations are more in your nodal or mesh equations, you must have experienced yesterday when the equations are becoming more, you are not able to get the correct answer, right? That's because of your not expertise of having KCL and KVL. So if that is the case, when you have more number of equations, then you should not go by inspection or by KCL KVL. You can use one more technique, which is little bit uh, complicated. Little bit. You should be good enough at linear algebra. I believe that you people are knowing about matrix theory and all these things, right? You studied that, right? How to find out determinant, eigenvalues, all these things. Okay. If you forgot, please keep those things on your fingertip, right? Okay. So what I'm saying, if such kind of equations you are going to have, where there are two independent voltage sources. Now you can sit down, Dinesh, no problem. Now it's not required. Okay. Now there are two independent voltage sources in your circuit, and there are n number of control loops, or k number of control loops are there. So you are going to have summation of k terms and summation something like k number of equations, right? And then you can write down in terms of impedance or the impedance matrix. So when you are going to write down this, it will be the impedance matrix. So that is what I was trying to tell you yesterday. You can write down the impedance matrix and the answer will be easier. So you can write down the impedance matrix. I believe you are expert of impedance matrix. Yes or no? If there is some circuit, let's revisit it very quickly. So same circuit. I want to write down. So this is I1, this is I2, and this is, which side do you like? This is I3. So can you write down the impedance matrix? So there will be 3 loops, 1, 2, 3, and 1, 2, 3. You need to fill the values. Can you do it in your notebook? Please do it. That is more important thing. You are not doing so. By the way, okay, Anvesh is absent, but this was his question most of the time, that I am not including V1. So V1, all the independent sources will not go here. When you are going to write this impedance matrix, it's equal to Z times I equal to V. So it will be multiplied by 3 things, I1, I2 and I3, and this side will be V1, V2 might be 0 or something here, right? So it's the same thing. Look, in the form of equations also you can write down, or you can write down in the form of matrix, whichever you like. And particular impedance for a given place, which is known as self impedance. So all this Z11, Z22 and Z33 are self impedances. If you are finding out the self impedances, those entries will be plus. Other entries might be plus, might be minus, depending on what loop you are creating. One more thing we have observed, whatever you are going to see here, same matrix you are going to see here, means the upper side of impedances are equal to the lower side of impedances. Such kind of circuits are known as, what do you think? Those are known as reciprocatory network. If both are equal, these green, and they will be equal, right? So can you write down and fill these terms? I am not going to fill these terms, right? You have to answer me. Okay, so here what I'm going to write down. Look, if this is R1, R2 and R3, sorry I forgot to name them. So R1 plus R2. Remember, this is not admittance matrix. If it is admittance, then it has to be 1 by R1 plus 1 by R2. Right? In this loop, oh sorry, only R1. Thank you. Only R1, because in this loop it's only R1. Right? Similarly, you can write down for others. I1 on the impact of I2, nothing, right? 0. If you are considering this as I2. If you are considering this as I2, there will be some number which is coming here, right? And other, tell me, that is minus R1. You have to tell me, I am just writing down. Minus R1. So third loop we are writing. In third loop, how many components are there? In third loop, how many elements are there? Oh, sorry. We are writing only 1 and 2. Sorry. I was writing, by mistake, I was writing Z33. Yeah, correct. Right? So similarly, you can fill other entries and you can find out this kind of matrix. Now, one more thing. If we have some matrix, I am going to call something called delta. Delta is determinant. Okay, this is the thing we are actually. I am following what Franklin Covey is following in his book. So delta, wherever you are saying delta, it's determinant, just delta. So Do we know how to find out delta of, okay, somebody can help me? So everybody know how to find out delta, right? What? How do you find out? So you are following this? Okay, A times BC minus Fi, something like this, minus D times. Okay. Do you know any other technique also? Because you might be knowing better techniques than me. Do you know any other technique? Huh? Tino multiply. Okay. Okay. So what's your name? So Naveen. So what he is saying generally, people are following whatever is here. We can write down here. Sorry. Right. Whatever is here, you can write down here. And as he is suggesting, we need to multiply this diagonally, right? Then this one, then this one, right? This is done for all three. It's done, so we are stopping here. But we need to complete the other side. So we have to start from here. But this multiplication will be in negative. This one again negative, and this one again in negative. You are aware of this? Okay. Yes or no? Divyanshu, no. Okay. So is that, do not feel shy. It's not a problem, right? So are you following till now? What is happening? So what exactly we need to do? If we have this green color box, which is matrix, where all the ABCDs are there, you have to extra adding two lines. If it is 3 cross 3, you have to add two columns here. If it is 4 cross 4, you need to add three extra columns, right? And you have to start from this entry, which is going diagonally, it's oblique, right? So you have to follow that way, and you have to cover three elements A, B, C, again three elements, and again three elements, and you have to start from here. You have to cover H, I, and C also, which is going forward slash way, right? When you are doing this, and the determinant is equal to ABC plus DFH plus EGI, and all the yellow entries are going to be negative. HBE minus IFA minus CGD, right? So that will be the determinant. Okay. Yeah. Mostly all. In my opinion, it works. Generally, it works. Or I'll ask some mathematician, or maybe I'll look at linear algebra one more time. 99% time, I haven't seen any entry where it does not work. At least in circuit theory, it works. Okay. So this is the one thing. So this is the most important background when you are following the third technique, where it's related with all this data. Now, one more thing, if you are observing these equations has V1, V2 and others are 0, then I1, I2 until IK you have the currents. So you are doing this one. Zi is equal to V. Or you are doing following. The whole matrix of Z multiplied with I1, I2 or anything. It may be any number. It might be some K also. Right? Okay. Battery died out. Sorry. Okay. So this is equal to V1, V2 and some more nodes. Might be 0, might be some VK, VN, anything. Okay. So when you are interested in writing down V2, how you are going to write down V2 in terms of this whole matrix? You are going to pick up the row of second row, right? You are going to pick up the second row, complete second row, which will be multiplied with I1, I2, I3. So this is going column and this is going row. So let's use this multiplication as new delta kind of thing, but we are going to name it as delta 2 1, where 2 is representing row and 1 is representing column. Although in book it's given delta 1 2, but there is by by considering the fact that yeah, so by considering the fact that all the RLC circuits all the RLC circuits are reciprocatory by nature. We understand this, right? Means Z12 is equal to Z21, Z21, okay, and vice versa, right? Or Y12 is equal to Y21. So if this is happening, means it's actually reciprocatory circuit. All the networks are reciprocal networks. And if Z11 equal to Z22, we are going to call that network as symmetric network. If you want to see the symmetric network, I can show you. You see both sides, you will see similar impedances, right? This kind of network is symmetric, and by the virtue of the network, which is RLC, it will be always reciprocal. It's not going to be reciprocal only in one condition, which we have not learned till now. We are going to learn it, which is known as gyrator. And I believe you have not studied gyrator anywhere, right? So we are going to study gyrator. Then it will not be reciprocal network. It might be symmetric, but not reciprocal in the case of gyrator. So accept that all the RLC circuits are actually reciprocal, not symmetric. Symmetric you need to make it. So this is symmetric, but sometimes it's not symmetric, right? So this is the case, right? And as I was saying you, we have to write down delta 2 1 or delta 1 2. What I mean to say, okay, it's written correctly. So from this equation, so there are list of equations are available till k number of equations, but we want only two equations because we are interested in v1 v2 i1 i2, and through which we will find out all the kinds of parameters. It might be z, y, or other parameters. So what I am defining here, I1 will be equal to delta 1 1 divided by delta, and we understand what is delta is. Delta is determinant and something delta ij. So if it is delta ij, so the definition which I have given, it's not complete one. I just told you how to see which one is row and which one is column. So here I is row and j is column, right? But when you are going to find out delta ij, remember the procedure says that remove ith row and remove jth column. Whatever is left, find out the delta and multiply that with minus 1 raised to ij, right? So if you are looking at yeah, I will repeat. Okay, so what I was saying, the most important part here, delta, to find out delta is not a problem. If you have a impedance matrix, you can find out delta without having any difficulty. The difficulty level is delta 1 1, delta 2 1, delta 1 2, or delta 2 2, because they are the matrices which are changing, and those matrices you need to find out by delta ij where you are going to remove ith row and you are going to remove jth column. What does it mean? Let's assume that this is the matrix I have. I'm interested in finding out delta is not a problem. Delta you can find out. We are following this technique just for one reason. It's going to be all the Laplace operators and might be not easy to get the answer by the technique we are following, right? A times B, C minus F, I, all these things will be, if all are Laplace operator, this multiplication number will go to S cube, right? So this will happen. So that's why I generally don't follow, but if you like some other methods of linear algebra, you can use that. Okay, and if I am interested in finding out delta 1 1, means I need to remove first number row, first number column. Whatever is left, find out the determinant of that, but you need to find out whether this whole network will be multiplied with plus 1 or minus 1. So, okay, so it has to be multiplied by minus 1 raised to I plus j. So that was one mistake. I kept multiplication, but it has to be plus. So if it is 1 1, so this particular thing will become plus 1, right? So you have to multiply with plus 1. If you go to other delta, which is delta 1 2, so what we are going to do? We are going to remove first row and second number column. So we are left with G, F, H, C multiplied by minus 1 raised to 3. This is 2, right? So this will give you minus plus, right? There are many other ways to define these deltas, but we are defining only this way. If you finding something different, like all other books are following different way, I am just stick to one book, Franklin Cousteau. Okay. Any difficulty in finding this? Okay. So we'll complete this method maybe after your exam. Tuesday you have exam. Okay. Any doubt? Right. So we are going to use this delta 1 1, delta 1 2, and we will solve maybe one or two questions, and then we will move next level, which is H parameter. Right? Yes, Ashwarya. Okay. You are doing this, so I thought. Okay. So let's write down in terms of questions. I have not made the question, so there is Bode plot. Then what is next? Impedance and admittance matrix. Then graph theory. Right? So this was something like 15 marker question. This might be 10 marker question, and this might be 5 marker question. Right? So it's in total 30, but so there is one bonus of two-port network. So those who do not want to get like 30 out of 30 or 35 out of 30, then they can drop two-port. Okay. And you can study more on other things, right? So two-port network, yeah, maybe 5. This is 50 minutes. No, it's like this. Look. Yeah, cut set, loop set, whatever we have studied. All the things. Right? So I'll make sure that it will not be copied from anywhere. Okay, these questions are not copied from anywhere. I make my own questions. Okay. Yes, yes. It's open book, open notes, but closed internet. Okay. So you don't need to mug up all the equations and all these things. Just you have to follow. Right? But have you ever given any open book exam? No, no, not my exam. Hmm? So my suggestion is, if you want to give open book exam and if you want to use books, then you should read books. Okay. Otherwise it will not be useful at all.